Welcome to the third episode of the CrackSense Project Data Stories 360 podcast. I'm Sandra Kolaric, Junior Communication Manager at Future Systems Hub, one of the partners in the CrackSense project, and I'll be your host for today's episode. For this episode, I'm pleased to welcome Nikos Arvanitis, a machine learning engineer at Synelixis. Nikos works on the AgriDataValue project, a sister project of CrackSense, and has also contributed to other Horizon Europe projects in precision agriculture, including Nestler and Georgia. His research focuses on applying artificial intelligence to agriculture, particularly in pest and disease recognitions and detection, as well as smart irrigation. Together, we'll explore how AI and data-driven technologies are supporting more informed decision-making in agriculture and the opportunities they bring for farmers and researchers alike. To start, could you introduce yourself and tell us what attracted you to applying machine learning in agriculture?
First things first, Sandra, thank you for inviting me to discuss about our research activities. My name is Nikos Arvanitis, and I work as an ML engineer in the field of AI for sustainable agriculture. What attracted me to this area is the profound. It is the real-world impact it can have. Agriculture is at the heart of some of our most critical global challenges. Food security, climate change, resource scarcity. So machine learning can offer powerful tools to not only understand these complex systems, but also actively improve them. The opportunity to move from reactive farming to a proactive data-driven approach that can optimize yields, reduce irrigation water waste, and protect the environment is what really motivates me.
Thank you for that introduction. What is your role in the AgriDataValue project, and how does your work contribute to developing data-driven solutions for agriculture?
So my role in AgriDataValue is the role of a data scientist and machine learning engineer. Together with my colleagues, I'm responsible for the development of machine learning models that power our data-driven agricultural solutions. In practical terms, my work involves different key areas, such as the development of a data pipeline that is the infrastructure to ingest clean and harmonized data from diverse sources, such as satellite imagery or drone imagery, IoT sensors, weather stations. Also, another key area, and the most important, is the model development and the validation. I develop and fine-tune machine learning models for specific agricultural use cases, such as pest and disease recognition, yield prediction, irrigation optimization. And another important thing is that I have to collaborate with and work closely with agronomists and domain experts to ensure that the developed ML models are working as expected. I have to translate the domain knowledge into specific model requirements and help design intuitive interfaces that include these ML models so that farmers can easily interact with them.
That gives us a good overview of your work. Artificial intelligence is becoming increasingly important in farming. And from your perspective, what are some of the biggest opportunities AI offers to farmers today?
I think the biggest opportunities lie in moving from generalized to personalized precision management. AI enables farmers to analyze vast amounts of data to make better decisions, So this whole process may include precision resource management on applying water, fertilizers, and pesticides only where and when they are needed. For example, AI-enabled precision spraying may reduce pesticide usage by up to 30%, 30% without compromising yields. Also, predictive analytics. We could utilize AI models to forecast weather patterns, drought risks, and pest outbreaks. And another thing is the autonomous decision making, moving from simple automation to intelligent self-optimizing systems that can handle complex tasks from planning to harvest.
Appreciate you breaking that down. A significant part of your work focuses on pest and disease recognitions. How can machine learning help detect these problems earlier, and why is early detection so important for crop production?
Uh, Machine learning, particularly deep learning, including computer vision, can totally change the way pest and disease is detected and recognized. For example, we could train machine learning and deep learning models using vast amount of images of diseased and also healthy plants to uh, drive these models be able to distinguish between health and diseased plants. Also, UAVs, drones may be used, drones equipped with multispectral or hyperspectral cameras to continuously monitor fields and provide warnings for possible pest presence several days in advance. And this early stage detection is critical because pest infestation may cause up to 40% yield losses annually. So detecting such a problem at its early stage means that the farmer can intervene with a smaller and more targeted treatment, which is not only more effective, but also uses fewer chemicals and saves money for the farmer.
You have also worked on smart irrigation solutions. How can data and AI help farmers use water more efficiently while maintaining healthy crops?
Yeah, well, smart irrigation, let's start from this. Smart irrigation leverages a network of sensors, for example, sensors for measuring soil moisture, soil temperature, air temperature, humidity, solar radiation, along with weather data to create a real-time picture, let's say, of the crop's water needs. So AI algorithms are able to analyze these data patterns to create precise and adaptive watering schedules. So instead of watering on a fixed timer, the system can predict exactly how much water each part of the field needs at a given time, given the measurements of the IoT sensors. So this whole approach can improve water usage efficiency by 30 or 50%. This can ensure that crops get the optimal amount of water for healthy growth, avoiding both water stress from underwatering and also avoiding root diseases from overwatering, which may cause increased soil moisture that attracts pests, for example, while also significantly conserving one of our most precious resources, water.
And you also mentioned different sources of data, such as sensors, UAVs. So, can you tell me how does bringing together data from different sources improve decision making on the farm?
Uh, yeah. The true power of AI in agriculture emerges when we stop looking at data in silo and start fusing it. So integrating data from different sources such as satellite imagery, drone imagery, IoT, soil and air sensors, weather stations, we are able to create a holistic and high resolution view of a field. For example, we might have satellite data showing us a stressed area of a field, but only if we combine it with soil sensor, we would be able to determine if this stressed area is due to lack of water, due to nutrient deficiency, or a pest presence. This multi-source data integration allows decision support systems to learn complex spatial and temporal patterns, leading to more accurate and actionable insights.
And many farmers are interested in digital technologies, but may wonder how practical they are to implement. What do you see as the main challenges and opportunities for adopting AI-powered tools in everyday farming?
Uh, there are some challenges, and this is a nice question. Uh, One challenge is regarding the infrastructure. Many rural areas still have limited digital connectivity, and there is a difficulty for the farmers to have good internet access. Also, there is the cost of the equipment to be installed and the possible uncertainty from the farmer side about the return of their investment. Another challenge is the lack of trust that farmers may have. They may see AI as something promising, but still unproven. So they may want to have stronger evidence of the real world performance before adapting it.
Thank you for sharing those insights. To conclude, how do you see AI and data-driven technologies shaping the future of agriculture over the next decade? And what impact do you hope projects like AgriDataValue and CrackSense will have?
Uh, I think over the next decade, we will see a shift towards the development of fully autonomous cognitive agricultural ecosystems. What does this mean? This means AI systems that do not just analyze data, but they also act on it. Uh, Multi-agent systems that would be able to manage everything from planting to harvesting with a minimal but essential human intervention. I think we will see more advanced multi-agent systems that could handle a multitude of tasks with a greater focus on agentic AI that can make coordinated and goal-directed decisions. As for the second part of your questions regarding projects such as AgriDataValue and CrackSense, my hope is that they will be something like a bridge between cutting-edge research and practical impact. So by funding collaborative research and innovation actions, such as these projects, it could be crucial for validating these technologies in real-world conditions, demonstrating the benefits of them, like reduced pesticide usage and water saving. Also for building trust by providing strong evidence for the farmers, and also fostering the collaboration between researchers, technology developers, and farmers to ensure the developed solutions are actually useful and accessible.
Thank you. And with that, we've reached the end of today's conversation. A big thank you to Nikos Arvanitis for helping us better understand how artificial intelligence and machine learning are being applied to agriculture, from moving crop monitoring to making better use of agricultural data. His insights have shown how research is helping to develop practical tools for farmers. To keep up with the latest news and developments from the CrackSense project, visit cracksense.eu. And thanks for spending this time with us. We hope you'll join us again for another episode of CrackSense Data Stories 360. Thank you.
Thank you too.